Hello my PU2 champions, welcome back to our channel Deeksha Karnataka. Today I'm here in the Brahmastra 2.0 with the chapter application of integrals, right? So we all know the kind of question that comes from this particular unit will be your one question 5 marker. So we'll have to again solve similar type of problems, right? And they're pretty easy in nature, right? Whether the question of ellipse or parabola, or combination of different 2D shapes with a line, or we have a parabola combination, line or circle combination, we'll deal with all type of problems and the PYQs. So without wasting time, let's start the session right away. And if you're watching me for the first time, do not forget to subscribe the our channel Deeksha Karnataka and join our WhatsApp community, because you get all the updates regarding your examination, regarding the videos which is coming up in the WhatsApp community only. Link for both, again you can subscribe right now, and link for the channel will be given in the description of this video. If you are here, if you're serious about your PU2 preparation, about your KCET preparation, then you are at the right place. Just you have to do one thing: follow us and leave all the concerns, all the worries to us, and we'll take care of it. Okay, so let's start the session right now with that. Now, so if you are, let's just starting right now, means if you're somebody that who got serious right now and there's a lot to cover, you are distracted from where to study, what to study, what to prioritize, you have too many questions right now in your mind, you're confused, but you want to do good. What you can do, simply take our PU2 target 90 plus crash course, and this will be the solution for everything that you are concerned about for your PU2 boards, for two reasons. Because this has very good amount of weightage in your KCET examination, so PU2 has to be taken very much seriously, and it's a milestone in your preparation, in your studies, okay, in the academics, getting a good score in PU2. For that, take the PU2 target crash course, and still from here also you can get a very good score in your boards. What is the offerings of this particular course? Check here: one-shot lectures, complete PYQ lectures, PC, MB, Kannada and CS. Yes, you will be also provided with CS and Kannada alongside with physics, chemistry, maths and biology. Lecture notes and PDFs, live doubt solving sessions will be there, dedicated WhatsApp community and channel, live recording classes, formula sheets, and of course our your seniors recommendation will be your PU2 dedicated test series. We had this as success blueprint test series last year. Again, improved and enhanced and latest version of the test series will be given to all of you as the part of this crash course, all at a price point of only 1000 rupees. 999 is the price of this PU2 target 90 plus crash course. So if you are starting the preparation right now, take the course. Link for that will be given in your description of this particular video. Okay, let's continue now. The first thing first is going to be our weightage. Have a look. So we all know the weightage of this chapter looks like very simple: one question, 5 marks. We're gonna deal with that. Next up, your content index. If you check what is there, sir, I have planned total of 12-13 questions for you, PYQs and most important questions, which will help you prepare the chapter in the best way possible. It has all the variety of questions into consideration, taken into consideration. Let's continue. So first question over here we have is: find the area enclosed by the circle x square plus y square equals to a square by the method of integration. Okay, so of course we know it's a circle, means pi r square is the area, but we have to get the result using the integration method. It's a PYQ of 2023. Please check. So circle looks like this, all right, and it's not symmetric, but understand it is going to be a symmetric figure. Okay, this will all be what, bacha? A minus a, sorry, plus a minus a and minus a, right? The radius is always a in the circle. In the case of ellipse, it becomes a and b, because there are two different axes, major and minor. Okay, so I'm looking to get the area of this. Let me divide this into 4 parts: part 1, part 2, part 3 and part 4. So if I want to get the area of the circle, I can write this as 4 times the area of part 1. 4 times the area of part 1. Okay, sir. So how do you find area of part 1, sir? Very simple. Integrate under this curve. What is that curve, sir? The circle's curve, which is given as x square plus y square equals to a square. Now to integrate this curve, I'm going to take what? Y dx, and the value of x from where to where? From 0 to a. From 0 here to a here. Okay. So what is the value of y over here? We're gonna find it out by making the y as subject. So we'll have y square equals to this a square minus x square, and y equals to root of a square minus x square. Now we can put the value of y back in our integral. We'll have area of the part 1 as integration of y dx, right? So integration of a square minus x square 0 to a dx. We all know this is the integration of what type? Particular functions. For that we have the result, if you remember, x by 2 times the same root comes a plus sign, a square by 2, a is a square, so like this, the same a square over here into sine inverse of x upon a. The limit is from where to where? From 0 to a, bacha. Okay. If you put a in the first term, it becomes 0. Check here. A square minus x square. X, if you take as a, it will become a square minus a square. So whole thing is 0. If you put over here, you'll get what? A square by 2 sine inverse of a by a. Sine inverse of 1. A by a is 1. Now when you take the lower limit, when you put 0 over here, 0 by 2 is 0. Everything becomes 0. So first term will be 0 when you put the lower limit. Over here, sine 0 by a is sine inverse of 0. Sine inverse of 0 is 0. Again, that will also be 0, sir. So we have this so far as a square by 2. Sine inverse of 1, sir, is pi by 2. So I have the answer as pi a square by 4. Now this is the area of your part 1. Area of the part 1 taken as per figure, you can see. Taken as per figure, you can see. So basically in this result, I can write this as 4 times of area of part 1 as pi a square by 4. 4 and 4 cancels. My result is, sir, pi a square. Square unit of course. A was the radius, and that we all know is the formula of area of a circle. Using the method of integration, and we used here particular function of this category. I hope you know the formula of the integration of root of a square minus x square. A very simple question for 5 marks. Next, find the area enclosed by the ellipse. Same result, exact same result. This also is a PYQ. So first, we know that very well that this will be of the same form. In this case, we'll have a major and minor axis, but they will be symmetric in nature. They will be symmetric in nature. So check. Okay. In this case, we'll have bacha here 0 and a, because a is the major axis, and this will be the minor axis as, as b. So I'm going to do the same thing, make the subject as y, and this part integration will be what? I. So it will become what? Y dx from where to where? I can take from 0 to a only. From 0 to a only. This will be my area of part 1. Area of part 1. Okay, chali. So once we have this, you can see here it will be symmetric in nature. Okay, AB, this will be minus a, right, bacha? This will be minus b. Okay, so this also is equal to this one, and they are all equal in nature. So I can just simply multiply this area of part 1 with 4 and get the required result. Okay, chaliye. So how do you find y in this case now? Y will be same result, y square by b square equals to 1 minus x square by a square. Continue, I'll get a square minus x square by a square. So I get y square as b square by a square, and the bracket will have a square minus x square. So this will give me the value of y very simply as root, if I take b by a, same thing we'll have here, a square minus x square. This is the y value we're going to use in the integration. Okay, limit, I hope this is clear. 0 to a, I have taken 0 to a by bacha because I have taken the given function in terms of the variable x. Okay, y is in the terms of the variable x. This y here is a function of x. That's why the limit is taken for the variable x. Okay, substitute back for the part 1. I'll have the area as there's a constant b by a. I can take it outside. Constant is what? 0 to so limit is 0 to a. Integration of the same thing. All right, with dx we know this result very well. Same formula, x by 2, root repeats, a square minus x square plus a square by 2 sine inverse of x by a. The limit is from where to where? 0 to a. Continue please. B by a we have. Put back a, this will become 0. We know that. How, sir? Because a square minus a square will be 0, right? Now, for this you'll have a square by 2 sine inverse of a by a is 1 plus, sorry, not plus, minus, no? Minus here, right? It's a lower limit. So, minus sign, minus. Check the lower limit. When you put 0, this will be 0 by 2 into 0 into everything is 0. And over here also 0. Right, sine inverse of 0 is 0, everything is 0. So my integration of for the first part is b by a. I have a square by 2 pi by 2. So this will cancel one of the a over here, and my answer is pi a b upon 4. Pi a b upon 4. So I'm looking for the ellipse, right? Area of ellipse. So area of the ellipse is given by 4 times of the area of part 1. So 4 times of pi AB by 4 cancels. So pi AB square units. So they do ask questions like this, deriving the area of ellipse, area of circle, or combination with parabola and straight line. We'll see all the different types of questions. Okay, don't worry, after this session you'll be very much comfortable solving any questions coming your way in the chapter application of integral. Okay, next, find the area of region bounded by the curve y square 4x y minus y axis. Okay, this is the combination of straight line and parabola. Symmetric about x-axis, right? Okay, and y-axis. So this one, this is the y-axis, and the line y equal to 3. Excuse me. Y equal to 3 line is over here, which is my required area, bacha. This right here is my required area. People, you might think or understand that this will be the area over here somewhere. No, this says with y-axis. Okay, with the y-axis over here. There is no x, so you're not gonna make this. You're not gonna join this part. Okay, that's not there because they have mentioned very clearly y-axis. So that is my required area. Okay, so this is my shaded region. How would I get this? If I call this to be, let's say, area A. So area A will be given by bacha integration of, let's say the limit is there for y, right? 0 to 3. Check here, 0 to 3. So right here limit 0 to 3. Since the given function limit is in terms of y, I'll write x as subject. So x dy, right? Because what is x actually? X is the function of the variable y. X is the function of the variable y. Let's get the x value from here. So we have y square equals to 4x. Very simple, x will be y square by 4. No problem over there. Substitute back in this integration. A will be integral from 0 to 3. 1 by 4 is a constant kept outside. Integration of y square dy. Okay, so we'll get here as y cube by 3 from 0 to 3. So 1 by 4. Put the value, y cube is 27 by 3 minus 0. When you put 0, it will be 0. So I have the answer as 27. So 1 by 4 into 9, right? 27 by 3 is 9. So my answer is coming as, the required area is nothing but 9 by 4 square units. 9 by 4 square units, please check. Okay, that's the required area that we have. Okay, the shaded region that I have mentioned as area A. Clear? No problem. Next question. Area bounded by the curve y equal to cos x between x to 0 and x to 2 pi. As I said, I have mentioned all the different types of questions. You can see it's pretty evident from the given statement. Okay, cos x curve. Cos x from 0 to 2 pi looks like this. Okay, this is 0. This right here is your pi by 2. This will be your pi. This is 3 pi by 2, and this here is your 2 pi. Okay, so if you break down into 4 sections, you'll have, check here, you'll have section 1, section 2, section 3 and section 4. Now there is a way to do this integration as area of part 1 plus area of part 2, right? Area of part 1 plus area of part 4 actually, and plus modulus of area of part 2 plus 3. Why that? Because 2 and 3 will be negative. I have to make modulus to get the area, right? We cannot take the negative as the area, so I have to add it like this. Otherwise, simply you can check here. Actually, area of part 1 is equal to area of part 2 is equals to area of part 3 and is equals to area of part 4. All these sections will have equal area. So simply find the area of one of the section, multiply by 4. Isn't it simpler and actually less calculative in nature? Yes, let's try that. So I'll get area of the part 1 as integration of what? The function here is what? The cos x. So cos x dx, the limit you check, 0 to pi by 2. 0 to pi by 2. Okay, I'll get what? Integration as sin x from 0 to pi by 2. Value you check now, sin pi by 2 and sin 0 is 0. So 1 is the answer for area of the part 1. Area of the whole thing, the whole curve, okay, the required area A, okay, will be part 1 times of 4. Part 1 times of 4, because they are all equal in nature. Answer is what, bacha? Very simple. 4 into 1. Answer is 4 square units. Answer is 4 square units. Please check. Does it make sense to all of you? Yes? Okay. Next, find the area enclosed by the circle x square plus y square equals to a square. We just did this question. Remember, this is a repetitive question, came in March paper as well, same as the answer of question number 1. Okay, why did I show you to show the same question over here? Because you can see the trend of the problems, okay, that they are repeating in nature. Check here, this was the question, right? Yes, got it? Exact same question has been repeated. Next, sixth one, same question. Check here, 16 June, 18 June and 22 April. The question has been asked again and again. Okay, same approach. Okay, you write y value as b by a integration what? Root of a square minus x square. Integrate this from where? What is it? So you'll have the answer as required area will be 4 times the integration of b by a 0 to a this thing dx. Your answer will come as pi ab. Same result. Okay, question number 2 basically. Next, find the area of region bounded between the ellipse. Now in this case they have given the values over here, so we'll again solve this question, no problem. Alright sir, so let's simplify this. Y square by 9 equals to what we have, 1 minus x square by 16. We'll get the same result, 16 minus x square by 16. So I get value of y square as 9 by 16 and not root. We'll have the bracket first, so bracket of 16 minus x square. So we get the value of y as 3 by 4, 4 square minus x square in the root. Now integration will become what? The limit, if you check this, the ellipse will be like this. Your major axis is what? Your major axis is what? Please check here, 16. It means this value will be 4, this will be 3. So integrate from where to where? From 0 to 4. 0 to 4, and you have to multiply here with 4, and the constant will come as it is 3 by 4. This is the required area of the ellipse. Okay, I'm writing this as area of the ellipse, let's say E. 3 by 4 I've taken outside, integration of 4 square minus x square, and we have dx. Okay, so the area of the ellipse will be what? Please check. This 4 and 4 is okay, we'll keep that later only. Okay, 4 by 3, 4 is a 12 by 4. Okay, and integration of this will be what? X by 2. So x by 2 into the same plus a square by 2 means 4 square by 2 sine inverse of x by 4 from where to where? From the limit 0 to 4. Okay, this is 3, right? Area of ellipse. Check here, put the value 4, it will become 4 square minus 4 square. So 0, it will be what? 4 square is 16 by 2 is 8. Sine inverse of 1. 4 by 4 is 1. Minus lower limit is both 0. Okay. 3, I have 8. Pi by 2, 4. What's my answer? 12 pi square units. This is your area of the ellipse E. Got it? Yes. Same approach, of course, with the values this time. So the question might come this way as well. That's why I've taken the different variety which is possible. Okay. Find the area of the region bounded by the ellipse. Now in this case, the major axis is y-axis actually. That's the only difference. So this is the major axis. Check here, this is your 2 and this right here is 3. Okay, so your choice. If you want, you can continue, change this time subject to be x or y, your choice, but we can go with y only. So I'll have here, check this out, y square by 9 equals to x square by 4 minus 1, sorry, 1 minus x square by 4, excuse me, 1 minus x square by 4, no, 1 minus x square by 4, so this will be what, 1 is outside, mistakes, excuse me, I'll get 4 minus x square by 4, so we'll have 3 by 2 root of 2 square minus x square, this is the value of y. Okay, now integrate this to get the area of ellipse as 4 times this integration. 3 by 2 is outside, integration for what? For same thing. I'm looking for x, no? So check here, this is the x is the variables, means 0 to 2 only will go, not 0 to 3. If you want to use 0 to 3, you have to make this as a subject as x, okay? Right now subject is y, okay? I have to make the subject x in that case, there will be different value. 0 to 2, same limit, same integration, 2 square minus x square dx. Check, 12 by 2 is 6, 12 by 2 is 6, and we'll have the integration as it is, x by 2 the same limit, and plus 2 square by 2, how much is that? 2 square by 2 into sine inverse of x by 2, from where to where? From 0 to 2. So 6, this is 0, gone, 2 square minus 2 square is gone, so 0, and too many cuts in this problem, I'll just change that. Okay, 1 second. X square, 2 square, okay, this is x, okay, x square, so I get this as 0, and this will be what? 2 sine inverse of 1 is pi by 2, and this is all 0. Cancel, answer is 6 pi square units, the area of the ellipse. If you want, you can solve this question in this way as well. If it was a MCQ, we can do a value is 2, b value is 3, answer is pi ab, so 2 into 3 is 6, okay? Formula approach, if you need, the answer is 6 pi. If it is a 1 marker, 2 marker like that, but this is a 5 marker, we have to do using integration only, okay? Next. Find the area lying in the first quadrant and bounded by the circle, first quadrant only. So circle is like this. First quadrant means from here to here. What is the r? R is 2. Okay, r is 2, and the line 0 to x. Okay, same thing. Means they can ask you to 0 to x equal to 1 also, but they have not asked that. They have given the limit to be 0 to 2 only. Okay. What about this? I can write this as y. Y will be what? Y will be 4 minus x square in the root. So y will be 2 square minus x square. Okay. I'm looking for only this part's area of part 1. We'll have this as from where to where? 0 to 2. This is nothing but 2 square minus x square dx. Integrate. So we'll have x by 2, same root repeats. Okay. Plus 2 square by 2 sine inverse of x by 2 from 0 to 2. What is this? This is 0. This is going to be 2 times of pi by 2. Sine inverse of 2 by 2 is 1. So pi by 2 minus all 0. We get this is cancelled. Answer is pi square units. This is the area of the part 1. Only the first quadrant they have asked, okay, only the first quadrant and the circles between the limit 0 to 2. Okay, this case the radius is also 2, that's why no problem. Otherwise, if they ask us 1, then we have to go only till this point. Okay, then the limit will be changed. Please check. Question number 10. Find the area bounded by the curve. Okay, modulus is there. Modulus will change sign at x equals to 0. So if I take this, if I define the function again, I'll have here x more than 0, you'll have this as x square, and for x less than 0, you'll have this as minus x square. So the curve will be like this, x square minus x square. The limit is what? Minus 1 to 1 from here. Minus 1 to 1. Okay. So my required area is what? This is the required area. This is the required area. Okay. Alright, sir. So we have to use the modulus for the negative area part. This is the negative area. I have to use modulus over here. And the other side will be positive only. Okay. So let's break it down. We can integrate it like this. As I've already taken this as minus x square, so we don't have to write modulus also. So let's integrate to get the final area. Integrate will be what? From minus 1 to 0. I'll simply take as minus x square dx plus 0 to 1 x square dx. Understand this very clearly. If you want to use modulus, don't use minus sign, because what you have done already is you have already made it as positive by taking the x square. Okay, it's your choice. Yes, nothing is wrong. Let's continue from here. Integration of this will be what? Minus x cube by 3 minus 1 to 0. Okay, plus x cube by 3 0 to 1. Okay, 0 to 1. Now take the minus sign outside. We'll have here minus 1 by 3, sorry, excuse me. We'll have this as 0 the upper limit. This comes a lower limit. You'll have here, I've taken the minus sign outside, right? Okay, so it'll be simply positive only, no? 1 by 3, minus 1 by 3 actually. And over here we'll have 1 by 3 only, no? Lower limit is 0. Check this out. We'll have the value as minus 1 by 3. Okay, plus 1 by 3. Alright, 1 second. Yes, plus 1 by 3. Since it is negative, means we have to use the modulus sign over here. Correct, no? The area will be negative because it is below the x-axis, so we have to use the modulus sign. You get here 1 by 3 plus 1 by 3. Answer is what? 2 by 3 square units. Answer is 2 by 3 square units. Next. Find the area of the region bounded by the line y equal to 3x plus 2, then x-axis. Okay, this curve. Alright. When x is 0, y is 2. X is 0, y is 2. So this is the point. When y is 0, it is going to be minus 2 by 3. Minus 2 by 3. And I want from minus 1 to 1. So this is minus 1, let's say. And this is going to be plus 1. So my area under consideration will be this one. This area is negative area. And this area right here is the positive area. Right? Means minus 1 to 2 by 3, minus 2 by 3, and minus 2 by 3 to 1 is the two parts. Okay. So the required area A will be integration of what? Of course, under the modulus, integration of 3x plus 2. Okay, from where to where? From minus 1 to minus 2 by 3, or of course with dx, and plus minus 2 by 3 to 1, same thing, 3x plus 2 dx. Okay, this we don't need the modulus because it is going to be always positive. This is going to be positive. 3x plus 2. Okay, clear. Let's continue with both the parts. Alright, sir. Let's start with this part first. I'll take this as my part 1 of integration. And this is part 2 of the integration, I1 and I2. So let's continue the first part over here. I1 will be, so we'll have integration from where? 3x square by 2 plus 2x. Am I right? 3x square by 2 and 2x in the limit, what is it, minus 1 to minus 2 by 3. Put it back. I have the values over here as 3 into upper limit, you're going to put, no, 3 by 2 we'll have here into 4 by 9, correct, no, 4 by 9, and over here minus 4 by 3 comes the lower limit, minus sign. Put this minus 1, you'll get what, 3 by 2, and over here you'll have minus 2x. Am I right? Please check. So far the calculation is looking good. Let's continue over here. We'll get this is 3 by 3 is cancelled, 2 2s are 4. I can take the LCM now. 2 into I've taken as x, so no, it's going to be simply 2 into 1, right? So minus 2. Okay, so we have this calculation as 2 by 3 minus 4 by 3 minus 3 by 2 plus 2 equal to, take the LCM, you'll have LCM as 6. 3 2s are means 2 2s are is 4, 3 3s are 3 2 just 6 means minus 8, 2 3s are means minus 9, and plus 1 6 means 6 to 12. I get the value as 17 and 16, right? So my answer is coming as I1 is equals to minus 1 by 6. 12 plus 4 is 16, 8 plus 9 is 17, negative. So minus 1 by 6, but there is a modulus over here. You can see this is the modulus, okay? So I'll put a modulus over here. Answer will be 1 by 6. This is your part of the area 1 square units. It's the area, okay? Next is what? Same thing under the limit, minus 2 by 3 to 1. So I2 minus 2 by 3 to 1, excuse me, 1 I mean 3x plus 2 dx, integrate now, we'll get 3x square by 2 plus 2x from where to where? From minus 2 by 3 to 1. Substitute back the value. 1 you put, 3 by 2 when you put 1, plus 2 when you put minus sign for the lower limit. You'll have here 3 by 2 as it is. For this you'll have 4 by 9, and there's a plus sign, so we'll get what, minus 4 by 3 actually, minus 4 by 3, so it'll be a minus sign only, no, it'll be a minus sign only, minus sign, right? Please check. Minus 4 by 3 and plus 4 by 9, correct. 3 3s are 9 and 2 2s are 4. LCM you check now. 3 by 2 plus 2 minus 2 by 3 and plus 4 by 3. LCM will be what, dear? Same thing, 6. 2 3s are means 9. Again 12, 3 2 3 are 6 means 3 3s are 9, and 1 6 are 2 6 are 12, minus 2 3 2s are, we have 3 2s over here, so I'll get 2 2s are means minus 4, and 3 2s are means 4 2s is 8. Check. 12 plus 8 is 20, plus 4 9 is 29, minus 4 will be 25 by 6 square units. 29 minus 4 is 25 by 6. I'm looking for the required area A will be I1 plus I2. So I had 1 by 6 plus 25 by 6. So 26 by 6, which is 13 by 3. 13 by 3. So this is my answer, 13 by 3 square units. This is your answer. Please check. Okay, from here to here, if you add both the areas, green and the blue one, the answer will be 13 by 3. Check the calculation one more time. Yes. Find the area bounded by the curve y equal to sin x between x0 and x2 pi. Okay, something which is very similar to your PYQ, very very important. Sin x will go from here. Excuse me. Okay, not looking perfect. I can do better. This is a little bit better. 0, pi, 2 pi. Since this is area 1 and area 2, and area 1 is equal to area 2, right? No, area 1 is equals to area of the part 2. Got it? So how to find the area of part 1? Very simple. So your required area will be given by twice of the area of part 1 first of all, and you will find area of part 1 in this fashion, twice of integration of what? Sin x from where to where? From 0 to pi with a dx, of course. with dx of cos. Check. So area will be twice of minus cos of x 0 to pi. Twice of, put here, minus cos of x is what? Cos pi. Cos pi will be what, bacha? I'll write cos pi only first. Then comes here minus sign, and we'll have here minus cos of 0. Okay? Twice of cos of pi is what? Minus 1, and cos 0 is what? 1. Cos 0 is 1. I get the value as twice of plus 1. Here minus 1 into 1 is plus 1. Here also plus 1. Answer is twice of 2. We get this as 4 square units. 4 square units. Check. Okay, 4 square units. That's your final answer. Okay, got it? Next. Okay, so your last question, 13th one. Find the area bounded by the curve. Alright, sir. X cube is like this. From where to where? Minus 2. Minus 2 to 1. So we'll go with this negative area and positive area. So we have to do what? We're gonna break the integration. X cube integration from where to where? Minus 2 to 0 will be in the modulus, and plus we'll have 0 to 1, the x cube integration in the positive side, so no need of modulus. Okay, check. We'll have here as x power 4 by 4, and we have here minus 2 to 0 in the modulus. Same way, x power 4 by 4, this is not modulus, okay, this is just the integration from where to where? From 0 to 1. Okay, so I get this as upper limit will be what? 0, and this will be what? Minus of, put the value, I get 16 by 4. Okay, over here we'll have simply upper limit will be 1 by 4, lower limit will be 0. Okay, I get this as modulus of minus 4 plus 1 by 4. I get this as 4 plus 1 by 4, which is same as 16 plus 1, 17 by 4 square units. Please check. This is your final answer. Okay, so this is the end of your lecture. Now, so this is where your chapter completes in your PUC Brahmastra application of integrals. I hope you enjoyed it. If I've missed something out, you can let me know in the comment section. If you're watching me for the first time, do not forget to hit the subscribe button, because we have planned amazing things for all of you to help you prepare in the best way possible for your PUC Boards and your KCET examination. And we love to help you in every bit possible. So for all the queries, just leave us a comment in the comment section. That's it for today. I'm going to see you again in the next class. Till then, take care. Bye-bye.